Find the most general form of the antiderivative for the following indefinite integral. So looking at this integrand here, we realize that we can't integrate the way that it's written. We're going to need to rewrite. So we want to rewrite the integrand. And in order to do this, we're going to need to apply the properties of exponents. So I'm going to take the integrand out here. We have t times the square root of t plus the sixth root of t to the fifth, all divided by t squared. So starting with the numerator here, we'll use our properties of exponents. This will be t to the first multiplied by t to the 1/2 plus t to the 5/6, and that's all divided by t squared. So we want to continue simplifying that first term here, and we can say that this is, if we have the product of two bases, same base, different exponents, we can add those together. So that's 1/2, or 1 plus 1/2, plus t to the 5/6, all divided by t squared. So the numerator simplifies to t to the 3/2 plus t to the 5/6, all divided by t squared. And so at this point, we now want to bring that denominator up. And there's multiple ways to approach this. What I'm going to do is I'm going to leave the numerator as it is, t to the 3/2 plus t to the 5/6, and I'm going to multiply this by t to the -2. And so we can now distribute t to the -2 through to both terms, and we have, this is equal to t to the 3/2 minus 2 plus t to the 5/6 minus 2. And in order to combine these together, we need a common denominator with each. So that's t to the 3/2 minus 4/2 plus t to the 5/6 minus 12/6. And this leaves us with t to the -1/2 plus t to the minus 7/6. And so we've now rewritten the integrand in its power form, and we're ready to go ahead and anti-differentiate. So we'll give ourselves plenty of room. So we have the antiderivative, or the integral of t to the -1/2 plus t to the -7/6 dt, and we're applying that power rule here. So this will become t to the -1/2 plus 1, all divided by -1/2 plus 1, plus t to the -7/6 plus 1, all over -7/6 plus 1, plus that arbitrary constant c. And so we can simplify this. This is t to the +1/2, all divided by 1/2, plus t to the -1/6, all divided by -1/6, plus that arbitrary constant c. And we can simplify here. We know that fractions in the denominator will flip, or we multiply by their reciprocal. So this becomes 2 by 1 times t to the 1/2 minus 6 by 1 times t to the -1/6 plus c. And we can either rewrite these rational exponents as radicals, or we can leave it as is. This is 2 times t to the 1/2 minus 6 times t to the -1/6 plus c. And this is a beautiful final answer. There's nothing wrong with this form. Alternatively, if we want, we could further rewrite this and say that this is 2 times the square root of t minus 6 all over the 6th root of t plus c. So whichever form you pick, just be mindful of your algebra.